Okay, last one. So all these ends are the same. It says N equals 4, which is a fourth energy level. At the fourth energy level, we can either have 4s, 4p, 4d, or 4f. Okay, so let's see what L values we can have. S, P, D, F, 0, 1, 2, 3. Okay, so we already have a 1 incorrect, and that is going to be A. L can never be negative. It goes 0 and up. L can never be negative. It goes 0 and up. 17. Can an electron or an atom be in an energy level described by the set of quantum numbers? Okay, so let's examine our quantum numbers. So N equals 5, which is our fifth energy level. N equals 5 is good to go, because we obviously have a fifth energy level. So C says N cannot be as large as 5. That is incorrect. Okay. So if we're at our fifth energy level, we can either have 4s, not 4s, 5s, 5p, 5d, and a 5f. So once again, we're going to do our S, P, D, F, 0, 1, 2, 3. Okay, so L equals 3. That is correct. We can have it if it's in the F. So L must... Okay, then it says no because L cannot be negative. Let's get our ML values. S, P, D, F. Oops. ML for S is 0. For P, it's -1 to +1. For D, it is -2 to 2. For F is -3 to 3. So ML can be negative. So this is correct. 3 more. Quantum numbers and periodic table. Which statement describing the periodic table is not true? All main group elements are found in the P block. So main group S and P block. So this one is already going to be a question because that may be our answer. Groups and families have the same meaning. Yes, there are our columns. Periodic trends are more difficult to distinguish as you progress down the periodic table. That would be correct. There are 4 blocks, S, P, D, F. That'll be correct. So our D block equals transitions. I'm just writing extra notes. Our S equals our metals. Our P is nonmetals. And our F is equal to, let me see real quick. Sorry, pulling up the spelling. Our F is our lanthanides. And our actinides. Okay. 19. Hund's rule states that blank. Remember, Hund's rule says that I have to spread out my electrons first. Spread, then fill. Okay, so that is incorrect. No two electrons in an atom may have identical sets of 4 quantum numbers. That is going to be Pauli. It is impossible to determine accurately both the momentum and position of an electron simultaneously. That he does not say that. Electrons occupy all the orbitals of a given sublevel singly before pairing. So spread, then fill. Pretty close. Last one, 20. According to Pauli, remember Pauli says no electrons with the same numbers. He also says an orbital can't hold more than 2. So each orbital has to have 2. And no electrons with the same numbers. So that would be, our error would be 1s3, because that means that there's 3 electrons in the s orbital. So that would be incorrect. And we are done with our review.